Yeah, no, thank you, Anna.
Okay, no problem. So we have two types of polymorphism. Okay, it is everywhere in all object-oriented programming. The polymorphism is two types. One is static polymorphism and another is dynamic polymorphism. Okay, so you can also refer static polymorphism as a compile time polymorphism or early binding. Dynamic polymorphism you can say runtime polymorphism or late binding. Okay, so the overloading and so method overloading and method overriding predominantly comes under static polymorphism, whereas overriding comes as a dynamic polymorphism. So let me tell you, like, let me launch Excel. Okay, suppose let's say, okay, this is your main program. Okay, and then uh, let's say you have a method here. Okay, method is m1, let's say. Here somewhere you are invoking m1 here in the program. Okay, so here what happens is, when you two things here, one is compilation, another one is runtime. Okay, so compilation means, okay, so whenever you try to execute any program, right, it internally happens two things. One is compilation, one is run. So compilation means here in the main program, okay, you are invoking a method m1. Okay, so what happens is during compilation time, okay, it tries to compile the instructions in the main program. Okay, and whenever the method gets invoked, okay, so it looks for, okay, by based on the parameters we pass in the method, right, it looks for, okay, here I need to execute m1. Okay, so what happens is it will establish a connection to the m1. Some kind of binding happens. Okay, so m1, so when it comes to here, okay, the compiler has to go and, or the sailor has to go and, invoke this method. So some kind of bonding happens. Okay, that is why it called com compile time. Compile, what's happening, compile time binding. Okay, also it is called early binding. Okay, suppose if the same if the same method, okay, so this adding this, the binding, okay, so it has to execute this one, right? So if it is, this binding is happening during the runtime, it is called runtime, or it is also called a late binding. Late binding means during the execution only you will know which method to execute. It doesn't initially knows which method to execute. So that's why, like, this binding concept came. Early binding, late binding. Early binding means during compile time your compiler knows which method to execute, whereas late binding, your compiler do not know. Only during the execution time, okay, it looks for the right method to execute, and then it will execute the steps in the method. Okay, so that's what, I, okay, try to put here. So static polymorphism is like, method overloading and method hiding, and dynamic polymorphism is a method overriding. Okay, so this is what I said. So when the function calls, okay, from the main method or from anywhere, basically, I just taken one simple example. So what happens is it looks which method to execute, okay, and tries to establish a connection to that method during compile time. That is called compile time polymorphism. Okay, and the best example is method overloading. And runtime polymorphism is during runtime only. Okay, your CLR binds that particular method. Okay, it is called dynamic polymorphism or runtime polymorphism or late binding. Okay, so now we'll focus on the overloading. Okay, so in the static binding or in the compile time polymorphism, there are two things, main things we have to aware. One is the overloading. Okay, and another one is hiding. Okay, so this one we already discussed. Okay, method overloading. Okay, so method overloading means, okay, it is an approach to define multiple methods under the class with a single name. So the method name is different. So method name is same. Okay, but how do you say it is overloading? So though the method name is same, the way you pass the parameters to that method varies from one method to another method. Okay, you can pass integer in one method, you can pass string in another method, you can pass integer first parameter, string as second parameter, you can pass string as a first parameter and integer as second parameter. So you're trying to define the different implementation based on the parameters we pass for that particular method. Okay, so method overloading happens with concept of passing different parameters for the same name. Okay, so this overloading, it's not only, it can happen within the class, it can also happen when you use the derived class also. That means when you establish a connection to parent to child through inheritance. Okay, so you have the public methods which are there in the base class automatically comes to the child class. So there also you can try to overload the methods. Okay, so method overloading can be done in single class itself or also in the derived class also. Okay, so this is what I was trying to explain. So method overloading means you see the same method name is same, method, but in first one you are not passing any parameters, in the second one you are passing only integer, third you are passing only string, fourth you can pass integer or string, then you can change the string or integer. So the method name is same, rather the parameters are different. So as long as you are trying to pass different parameters, or I would say different signatures, okay, you can achieve method overloading. Okay, so the brilliant example which I can give you for in CH is the write line built-in uh, function, right? Built-in method. Using write line, you can print integer value, you can print float value, you can print string value, right? We have been printing, we have been writing so many programs with write line, and we are printing almost like all the required data elements, right? So this is a brilliant example for a overloading. Okay, so then let me go to some examples. Okay, I think I have already launched it. Okay, now here see, so I mentioned that method overloading can be done within the class and also when we do inheritance, and we can achieve that in the derived class also. Okay, so first I'm focusing only within the class. Okay, so now you see it's only one class. Okay, and I have a method, its name is method name is method, so it doesn't take any parameters. Okay, the same one whatever I have shown you in the PPT, right? And the second method, integer value, third method, string, fourth method, integer and string, fifth method, string and integer. Okay, so within the same class you're trying to override or you're trying to overload the same method by passing different method signatures. Okay, and here I'm just trying to create the object for the class. Okay, and I am invoking the different methods without any parameters, with the integer value, with the string value, with the integer and string and integer. So it just prints. I just a simple example that like how the what's happening, how this overloading works. Okay, I just printed it just to show that how it works. Okay, so this is within the class, and if you see, okay, so here I try to show you how it works when we have base and child class. Okay, so here if you see the class 1, okay, which contains two methods, add method and sorry, same method, add method, but two different signatures. First method takes integer as a parameter, and the second add method takes floats as a parameters. Okay, and then I have the class 2, which is getting inherited from the class 1. Since the class 1 contains public methods, automatically these two methods available in class 2 as well. Okay, so what I'm going to do in class 2, apart from whatever I'm getting inherited to add integer and float, I'm adding one more method to concatenate strings also. Okay, that means class 2 contains the add method, which has the capability to pass integers or to pass floats or to pass a string value. Okay, so here I created the object for class 2, and I have invoked add method for three different uh, signatures. One is to add integers, one is to add floats, one is to add strings. Okay, it just prints. So basically, just try to understand that overloading is possible within the class in different classes also using inheritance. Okay, I think this one pretty much covered, I believe, but I think this should be okay. I think this is the one. Add float string. I think this should be okay. Okay, so this is what method overloading. So basically, you try to understand that whenever we say method overloading, it is a static binding or early binding, okay, or static polymorphism. The compiler tries to establish the connection to that function during compile time itself. How it happens? Based on the parameters we are passing, right? So it knows that, okay, this guy is passing this add method and he's having, okay, two float variables. Okay, so when I see I have same add method which has three different parameters. Since this guy is passing only integers, okay, let's bind it with this first method. So it understands actually, okay, during the compile time itself. Okay, this operator overloading, I will just wait for a minute. Okay, I don't want to confuse because it's different, it works. Okay, and it may create a confusion. So I will explain you later operator overloading. Okay, so the second one is method overriding. Okay, so let's see here. Just remember, method overloading, operator overloading, method hiding, these three comes under static polymorphism, and method overriding comes under dynamic polymorphism. So so far I have discussed only method overloading. Okay, now I'm moving to method overriding, that is runtime polymorphism. Okay, so here method overriding. So if you see here, so in the method overloading, what's happening? The method name is same, but the parameters are different. Okay, but in method overriding, okay, method name is same, okay, and signature also same. Okay, so method name is same and same, that's why I just highlighted same signature. Okay, so if you see the process of re-implementing the super class, so I said non-static, non-private, non-sealed. Okay, it has to be non-static because if it is static, you cannot create the object instance. It has to be non-private because if it is a private method, you cannot inherit in the child class. And if it is a sealed one, there is no way you can inherit. That's why I just said non-static, non-private, non-sealed. So you are trying to declare a method in the base class, okay, and that class you are trying to inherit in the derived class, okay, and since the method name is same in the base class, you have the ability to change the way it executes, or basically the function body you can override in your derived class. Okay, so basically, where exactly we use is, okay, suppose normally in the parent classes they keep the logic very general, okay, and they leave it to the developers, okay, who are going to consume that generic class, okay, to implement their own logic in the subclasses or in the derived classes. So let me show you the overriding here. Okay, here you see the class 1 contains one method called show. Okay, so remember guys, whenever you do the override, right, from base class to derived class, you have to use this virtual. Okay, virtual means you are telling the compiler that, hey, like, in my derived class, okay, I may change or I may override this particular function. Okay, so I have defined a virtual method show in the parent class called class 1. In the class 2 I am overriding class 1, okay, and I am using the same method show to write a different function body. Okay, so remember, whenever you use override, the base class method contains virtual and the derived class method contains override. Okay, so here I try to create the object for class 2 and I'm printing show. So since, okay, so here what happens is, when you do the compilation time, right, that time main method do not know which method it has to execute. It has to execute from the parent class or child class. Okay, it cannot identify, okay, because method name is same, okay, and two methods are not taking any parameters, so it is not possible for the compiler to identify which method, or which method means whether it has to execute the base method or the child method. You do not know. That's why it's called late binding. Only during the execution it will come to know. So I just print child show method because I have overridden, and my overridden method contains child class. Okay, but in the parent class method it has parent class method. Since it is overridden, it is printing the value from child class. Okay, let me show you a few more examples. Okay, so here I can explain you by taking a real-time example. So here, okay, so here I have a class called employee. Okay, and this employee class, if you see, I'm using 4 different variables which contains get and set. Can anyone recall what is this get and set? Any one of you try to recall where we use this get and set. It is a property to initialize the values for this variables in the class. Okay, so it's a default values I'm setting up, okay, using get and set. And there is a method, okay, if you see, it is a virtual method to calculate the bonus for an employee. Okay, by it is I'm fixing it is like 50K as a bonus as a default. Okay, so in general, all employees are supposed to get 50K as a bonus. Okay, but there are some exceptions. Okay, suppose if the employee is a software developer, okay, what I'm saying is, okay, if you see, I'm overriding the same calculate bonus method. Okay, and here I'm saying don't fix with 50K, based on his salary, give 20%. Okay, so here in the base class with the virtual method, I have a static value for the bonus, but but there are some exceptions. Developer has to get 20%, so I am overriding calculate bonus method in my derived class by using override keyword. Okay, and also I am trying to create one more class called manager. Okay, same employee base class. Okay, since he's the boss, okay, what I said is, if it is a developer, 20%, but if it is a boss, it is 25%. Okay, so by default it is 50K, but only exception is if it is a developer, 20%, if it is manager, 25%, if it is admin, I say I did not mention anything here. If you see, that means he will get by default 50K as a bonus. Okay, so here I just try to create the objects for employee, okay, for developer one, for manager one, and also for admin. Okay, and try to print the values. Okay, I'm just printing the developer gets 20%, manager gets 25%, and admin gets by default 50K. Okay, so this is the classic example, because like you make a generic value in the parent class method, and you are deriving, okay, a specific the bonus method with a new logic. This is like one of the example where we can use method overriding. Okay, okay, now let's try to understand the difference between method overloading and method overriding. Okay, so overloading is, as I mentioned, it is the method name is same but different signatures. Okay, and overloading can be done within the class as well as within two different classes by establishing parent-child relationship. Okay, so method overloading, you do not require any permission. Okay, you do not require, because if it is public, okay, already it is already available in the derived class, so you can automatically override it, overload it. Okay, and as I already mentioned, it is to implement the static polymorphism, right? And we do not require to use any specific keywords like override or virtual for overloading. But whereas if it is overriding, okay, it is method name is same and signature also same. And overriding is possible within the derived class. Okay, and you have to use two keywords. One is virtual and one is override. And overriding is to implement the dynamic polymorphism, right? And I said one statement: to override a parent class method under the child classes, first the child class requires to take permission from its parent. Okay, so how it is possible? Because you are indirectly telling the your derived class, okay, saying that, hey, I have already declared my method as a virtual. That means I am giving you the permission to override. So wherever you say a virtual, that means child knows, hey, this method I can implement on my own. So let's do it by using the override keyword. Okay, so this is about uh, method overloading and method overriding. Okay, then one more thing is called method hiding. Method hiding is again one way of implementing compile time polymorphism or static binding. Okay, method. Okay, so method hiding is almost similar to method overriding. Okay, if you see in method overriding, the child classes re-implement their parent class methods which are declared as virtual. That means the child class re-implement the parent class methods with the permission of the parent class, because here in the parent class the method is declared as virtual, giving permission to the child class for overriding the methods using override modifier. So this we have been discussing in the previous slides. Now in method hiding, sorry, 1 minute guys. Okay, so in method hiding, the child class can re-implement the method of parent class even if they are not declared as virtual. Okay, by default it has to be virtual in the parent class so that you can override using override keyword. But okay, you can still implement the new mechanism of that method, okay, without declaring virtual and override commands. How it is possible? It is possible with a new keyword called, or it's called with a new. If you see here, public void display. Okay, and one is public virtual void, right? So if it is a virtual, normally you do the override using override keyword. Okay, but here I'm not using the override keyword. You see, I'm not using override keyword. Rather, I used a keyword called new. Okay, this is the way of hiding. So when I say method hiding, basically means it is as good as you're trying to hide the parent class method and executing your own method in the derived class. Okay, so let me show you one example for method hiding. That way your doubts will be clear. Method hiding, right? Okay, so I just taken one simple example. If you see here, the parent class contains two methods. One is virtual method and one is the normal method. Okay, and in the child class, which is derived from parent class, okay, since the show method has already declared as virtual, you can do the override. Okay, you can do the override and you can write your own implementation logic. Okay, but for display it is not declared as a virtual. Okay, but I still wanted to do the overriding of display, which I can do using new keyword. Okay, so if you see, like in the same program I'm trying to implement method overriding by using virtual and override, and I'm trying to implement the method hiding using the new keyword. So basically what I'm trying to say is that though you do not declare your base class method as virtual, still you have the ability to override that particular method to implement your own logic by using the keyword called new. Okay, so if you see here, I have created a child object obj. Okay, I'm trying to print show and display. Since we are overriding from the base class, it's supposed to print whatever the logic we have written in the derived class. So it should print child class show method, child class display method. Okay, so basically I explained you about the overriding. So basically overriding is like, no, if you have a specific logic you have to implement in the derived classes, you keep it very generic at the base class, and when you derive the derived class, okay, and you try to implement your own logic, like we showed one example that employee have the bonus 50K as fixed, but when you derive for a developer, when you derive for a admin, when you derive a class for the managers, you are overriding that particular method, the bonus method, by your own logic. That's where we normally use the method overriding. And method overloading, we have been using so many times, right? We have overloading for constructors, right? We were passing so many constructors with different parameters. Okay, basically your idea of implementation is same. Okay, and I remember like we explained one day, right? Or okay, so get area is the method we used. If it is rectangle, we have a different formula to get the volume. If it is circle, it's a different formula. If it is cuboid, it's a different formula, right? So based on the type of the object or the shape of the object, right, we use get area method to implement. Okay, so I hope you are clear with the method overloading and method overloading. Okay, and also now method hiding. Okay, now uh, just wanted to wrap up this oops programming, but just wanted to tell you about a few things about partial class and sealed class. I know we discussed during this and in earlier slides
Yeah.
when we
Yeah.
started object-oriented programming.
Yes.
Okay, right? Okay, so partial class. Okay, so as the name depicts, it's a partial. That means suppose you are working on a big project. Okay, and and suppose everybody is using the same class, but the developers who are working on the project are on the specific class. Okay, suppose like I got to implement two methods, you got implement two methods, another one got implement two methods. So six methods, three programmers trying to implement, but the class is same. Okay, so in this case, uh, I should have the ability to create two methods. You should have the ability to create two methods, but the problem is class is same. That's why what is, because like if I start coding my class, okay, there is no way you can use my class unless I commit that code, right? So that's why like I will declare the class as a partial, and you can also declare the class name as partial. Okay, it's basically you're dividing the entire class into multiple files. Okay, I have my own file called A, you have your own file called B, okay, another one called C. Okay, so when we club all these three partial classes, okay, or these three partial files, right? When you actually compile, what happens is it looks for the partial class name. Okay, if the partial class name is same, it will try to club all these three files from my file, your file, and everybody's file. It will club into one file and tries to compile it. Okay, so that is the real like, classic example for a partial class. Okay, I will show you like how we implement in the program. The same way, the same way. Okay, so I said like I'm implementing two methods and you are implementing two methods, right? But let's say class contains four methods. Okay, and I said only because I have, or I'll say class contains six methods, right, total, and I'm implementing only two. Okay, but okay, the remaining four methods, right, I can declare in my program as only partial. Okay, that means okay, I'm only declaring the method, but it's not my responsibility. Rather, my another friend who is creating the partial class, he is taking care of that other method, but I'm not responsible. That's why I will only declare that method as a partial, so that when the class is getting combined, okay, during the compile time, hey, like Venus file contains one partial method. Okay, but let me check like is there any method or this method has been implemented by any other bodies. Okay, it will say your file. Oh, okay, you already implemented that method. Okay, let's use that function body to club it. Okay, let me give you one example, that way you'd be clear. Okay, this is partial class, right? Okay, you see here, look at the right side. I have two files, partial employee one, partial employee two, and my main program is in program.cs. Okay, if you look at the partial employee one, let's say let's say like I have taken care of this file. Okay, so I have only declared, okay, four variables with the get and set. Okay, And if you see, two things you have to remember here. Okay, one is I have declared my class as a partial class. Okay, and this class is under the namespace of partial class demo. Okay, so here all my file contains only the variable declaration. I did not include any methods. Okay, let's take underbody who created the second file. Okay, okay, here again he declared as a partial class, name is partial employee, and this guy taken care of implementing the methods, two methods. One is display full name, one is display employee details. Okay, and since it's a partial class and the name of the class is same, partial employee, and see partial employee. Okay, so during the compile time what happens is, okay, I mentioned in two separate files, so that the compiler looks for this all the CS files and see, okay, there is a partial class name, so look at all the CS files to see and combine. So it combines these two CS files into one. Okay, and then what happens, if you see here, the partial employee is the class. I have created one object emp. Okay, and I have initialized the values, and I try to print the values by invoking the methods. So if you remember, the initialization part is in the first class. Okay, and methods I have written in the second class. So two different class files, but since both class contains the partial class, which is partial employee, right? So I'm able to use without any problems. So if I execute, okay, so the variables has been taken from one class and the printing is happening in the another class. Okay, and I told yesterday how to create separate files. Go to the particular, in the properties, go to the class program name here and try to say add. Okay, add new item. It will ask what is the CS file you want to add. Okay, this is about the partial class. Okay, but look at the partial method. Okay, so now here see, again I have two classes, partial class 1, partial class 2. Okay, look at the class 1. So partial class 1 contains, okay, one method, okay, which has the implementation part also. Okay, but another method I have with only partial, because I know you are the one who is creating or who is writing the actual function body for this partial method. I just created a partial keyword. That means my class contains a partial method which I have not implemented. Rather, the implementation is available in another file. Okay, so then if you see this partial method, okay, it should be implemented in another place. So I have implemented in another class. Okay, so I implemented in this class. So class 1 contains only the declaration, whereas class 2 contains the actual implementation part. And in the main program, I'm just doing the same thing. Create the object and try to invoke the public method, then try to, okay, let's see here. Okay, it's just a simple example, to show how this works. See, normally what happens is, okay, I just mentioned here, where exactly we use these partial classes. One is I mentioned, if you are working on a larger projects, if more than one people are working on the same class, okay, unless I commit the class file, there is no way you can access. Okay, and it may take 1 week or 10 days for me, because I have 10 methods to implement in the same class. Okay, what we do, instead of waiting for me to write the code and commit, okay, we can declare the class as a partial class so that everybody can work on their own class file. And when we merge everything into a project, then it will combine during the compile time all the classes, so it will be all the class files, so it would be easy. It's basically programmer friendly, to be frank, for partial class. Okay, and one more thing is, see, whenever we work on this, the framework, right? Okay, so framework is basically like, already the logic is there, some code is already there in the framework, and we just need to customize based on your needs. Okay, so whenever you use these frameworks, right, already there is a existing code available, right? Already some code gets invoked internally when you start working with frameworks, right? You will see that the code is getting added automatically. Okay, so that is, so basically like in those cases, okay, they declare internally, they declare as a partial class. Suppose like I am creating a program using the framework, and if I declare my class name as like some student info or employee data. Okay, what happens is, when I start implementing the framework, what happens is internally, when it creates the source code, automatic source code, it tries to use the class name which I mentioned, like employee or student, and it will say, hey, when is trying to add additional logic, okay, and his class name is employee, okay, but I already have some set of code which can help Venu to derive the logic for employees. So what it do, it will say partial class employee, and within that class it tries to write whatever has been written using the framework. Okay, so same way, partial methods we already just discussed. I now sealed class. Okay, so sealed class, it's as the name depicts, it's sealed. You are not allowed to create or to derive a new class using sealed class. It's like hang on there only, it stops. There is no further cloning or inheritance. So you have to use the keyword called sealed. Okay, so the method that is defined in a parent class, if that method cannot be overridden under a child class, we call it as a sealed method. Okay, so that means by default every method is a sealed method, because overriding is not possible unless the method is not declared as virtual in the parent class. If a method is declared as a virtual in class, any child class can have the right to override, right? If I keep it as virtual, then you can override, right? Then you can override. But if you don't want to override that, you have to use sealed. So if you see here in the class parent, my method is show, which is set as virtual. And when I inherit the parent class within the child class, okay, it is virtual, so it is allowed for me to override. So I said override, okay, and show method, and I wanted to stop this method here only. I don't want my further derived class to use this method, so I said sealed. Sealed means, okay, let's stop it, don't do any kind of overriding in the derived classes. So when you say, the moment you say sealed, it is the function is available only up to this child class only. When you try to inherit the child class in grandparent, this sealed method will not be inherited because it is sealed. Okay, let's take one example. Okay, here, okay, okay, here you see employee class. Okay, and I have 2 or 4 variables: employee ID, employee age, name, and address. Okay, and I have 2 methods: get employee data and display employee data. Okay, 2 methods. And if you see, I have declared as virtual. Okay, that means I have the ability to override in my child class. Okay, now I see I have overridden the employee class, or I have inherited the employee class within the manager class. Okay, and I try to override. Okay, I try to override here. See here, override. Okay, override. And look at look at the prefix I have given for class. I said sealed. That means let's stop implementing the methods for get employee and display employee here only. Okay, if you try to create a another class based on manager, okay, there is no way this methods can be can be overridden. Okay, you are only stopping the basically the functional implementation stops here. Okay, you cannot override, but you can use because it is a public. You got it right. In the parent class, I have declared virtual public. Okay, so in my child class manager, I'm able to override because it is virtual. Okay, but since the class is declared as a sealed, okay, when you derive a new class using manager, you will not be able to override the methods, but you will be able to use that methods. Okay, so let's say here, so manager, right? So manager, I am creating one object and trying to print the get employee and display employee data. So whatever is there in my child class, it just prints it. So basically when you are implementing inheritance, there is one point you know that, okay, there is no way you can change the functionality of that method. If you are sure, then you make that method as sealed or make that class as sealed. That means nobody else, whoever is deriving that particular class, they will not be able to override the function implementation. Okay, this is about sealed class. Okay, and let me, okay, okay, so static class, I think I have been explaining about static class, so I don't want to repeat here, but there's one more thing called extension. Okay, so in inheritance, let's say you have a class which contains two public methods. Okay, it's a base class, and if you want to add another method in that class, what you do, you normally create a parent child relationship. You do a single inheritance. Okay, and so if it is inheritance, automatically the two methods which are there in the first class automatically comes to the derived class. Then you will implement one more method in the child class. Okay, that is one way. So basically you're trying to leverage the same functionality which is there in the base class, but just you are adding one more method to your derived class. That is the normal way of doing or implementing inheritance. Suppose, let's say you don't have the code available for the class. It was some long time back you got the class. Okay, long time back you got the class, right? Okay, so suppose if you don't have the source code available, okay, but still, because if there is no source code, there is no way you can inherit, right? Because you need to have the source code. Okay, so suppose you don't have the source code, but still you wanted to leverage the base class and you wanted to add one more method. Okay, so that's where it's called, there is a concept called extensions. Okay, so extension method, okay, is an approach to extending the functionality of a class. That means adding additional variables or additional methods. Okay, in the future, if the source code of the class is not available or we don't have any permission in making changes to the class. Okay, so normally you do using inheritance, but now with this extension method, you can do the, or you can extend the functionality of the existing class. How it works, let's see. Okay, so here if you see, my old class, okay, contains two methods, one variable integer and two methods. Okay, and in the new class, okay, so I am not using inheritance here, I'm using a different method, okay, called extension. Okay, so here how do you here is, if you see here, I have test1 and test2 in my old class, right? Okay, and in the new class, you see here, It's a new class, but when I am defining the method here, like test3 or test4 and test5, okay, if you see, look at the first parameter. Okay, I'm saying this old class, this old class, this old class. That means what I'm trying to convey to the compiler, that like, hey, there is a class called old class which is already available somewhere, okay, in our project. Okay, so try to club these three methods, test3, test4 and test5 to that class. Okay, so you are giving the instructions to compiler that I have three more methods, though I have created these methods in my new class, but B assign these three methods to the old class. Okay, and if you see in the program, I have created the old class, right? Old class initially contains only two methods, but by using the new class, I have added three more methods. Okay, and I aligned to old class. That means old class now contains five methods, right? So I have created the object for the old class, and you see I have invoked all five methods using the old class object: test1, test2, test3, 4 and 5. So here, if you see in the new class, I have did not use any inheritance here. Ideally we use inheritance to add extra or to get the properties from the previous class, but here I declared a new class, but I said, hey, I'm creating a new class, but the methods I'm going to declare, they should be part of the old class, right? So this is how it works. Extension means you're trying to add additional properties or additional methods to the existing class without inheritance. Okay, rather using a new class, but giving the parameter as a old class. So it knows that you are passing a class here. Okay, then that means this method should be aligned to this class. Okay, so let's try to execute. It will just print all method 1 2 3 4 5. Okay, so the thing you have to remember is that I have created the object based on the old class, not the new class, and I have executed all five methods. Okay, so yeah, I think that's all for today. Any questions? Overloading, I still need to explain operator overloading. Okay, I purposefully, there is a purpose why I'm not explaining today. Okay, it will create a lot of confusion. Okay, but I will explain. Okay, it's in my queue. But are you clear about other things? Method overloading.
Yeah.
Okay, and method overriding. Okay, then method hiding.
Yeah.
And then revisiting the partial classes and sealed classes, static and extension. So with this, like, I am wrapping up the object-oriented programming concepts. Okay, so tomorrow we'll start, because we have so many things: exception handling, file processing, multi-threading. Okay, and also I need to introduce you some of the frameworks as well.
Yeah.
Okay. Okay, so I will share this PPT today, because now we are pretty much done with all the OOPS concept. So I can send you this file. Okay, I will send you in the WhatsApp group, download, and I will also send you the programs which we have been discussing in the last 1 week. All those in a zip file I will send. So download and load into your Visual Studio, and try to practice. Since, like, I make the program names are very familiar with the subject, with the the process whatever we are doing, right? If it is extension,
Yeah.
I try to keep the same program that will be easy for you to identify the programs, so you can easily refer the programs and try to execute and try to establish a connection between your theory part and the implementation part. Okay, so with that I will wind up for the day. We'll meet tomorrow same time, and we'll go with a different topic. Probably we'll complete tomorrow exception handling, because we have not
Yeah.
covered yet exceptions.
Yeah.
Okay.
Okay. Yeah.
Okay, all right then, thank you very much,
Yeah.
and we'll
Thank
meet
you.
tomorrow same time.
Thank you.
Yeah. Take
Yeah,
care.
thanks.